Welcome to the video on ionic bonding. This video is aimed at Edexcel topic 2 of additional science. Okay, so to start off with, we're looking at the differences between atoms and ions. This is a really common sticking point for people where things go wrong. So first we need to understand that an atom has an outer shell. I'm just going to use X for now to signify a random atom. We should by now know that our atoms can fall into 8 different groups, groups 1 to 7 and then group 0. Apart from group 0, all the other groups have atoms with an incomplete outer shell. That means that there are spaces to add electrons on, or a possibility that electrons will be lost from that outer shell. That's because an outer shell either likes to be full or empty. Just as a quick recap, the first shell of an atom takes 2 electrons to be full. Our second shell takes 8 electrons to be full. Our third shell also needs 8 electrons to be full. And our fourth shell can hold 2 electrons, as we only need to know up to 20. However, it's not full at that point, so we'll ignore that one for now. So going back to our discussion about the differences, if we draw an atom of sodium as an example, sodium has an atomic number of 11. This means it has 11 protons and 11 electrons. Sodium also has a mass number of 23. Now the mass number is made up of the number of protons plus the number of neutrons. So 23 minus 11 leaves us 12. So we know it has 12 neutrons. Now unfortunately that one electron in sodium's outer shell means that it's unstable. An atom likes to have either a full or an empty outer shell to be stable. Now it needs to lose that one electron because it's easier to lose one to get to 0 electrons in the outer shell than it is to gain 7 more to get to 8 electrons in the outer shell and be full. So an ion does that, it gets rid of that outer electron. Obviously if it was a number close to 8, so for example oxygen in group 6, it would be easier to gain 2 electrons to become full than it would be to lose 6, but we'll stick to sodium for now. So here we have a sodium ion. Now as you can see, that electron in the outer shell has gone missing, it's been taken off, it's been removed, it's gone to a different atom to make sure that a different atom has also got a full outer shell, and this is how ionic bonding works. But our ion is now drawn in brackets and it has a charge on it, which is the little plus in the top right hand corner. Now because electrons are negative, if we've lost something negative, we are becoming positive, which is why sodium has a positive charge. If we count now, our number of electrons is 10. Our atomic number will remain the same, so we will still have 11 protons. Now our mass number will remain the same as well because electrons have a negligible mass, so our number of neutrons will also be 12. Now just a reminder that if we did change the atomic number, so we changed the number of protons, we would change what element we had. It would no longer be sodium. So the number of protons has to remain the same. Okay, so in the last slide we saw that sodium lost that electron. It doesn't just disappear into thin air, it does have to go somewhere. So in an ionic bond it will go to another atom to form an ion, and then those two ions will come together to form an ionic bond. So ionic bonds happen between atoms with a positive and a negative charge, and the electrons will be transferred between the two atoms to form two ions, which will then be electrostatically attracted to each other. So here we have a sodium ion and a chloride ion. Now we don't need to show the outer shell on the sodium because it's empty, so we can just put Na. For the chlorine we do have to show the outer shell because it's now full. We don't have to show any other shells when we're drawing our ions like this. As before, we've got our little charges in the top right hand corner. Sodium has lost that electron, which I've put in red on the chlorine, and has become positive. Chlorine has gained that electron from sodium and has become negative. Metals will keep the same name when they become ions, however non-metals will change. So our chlorine now becomes chloride. An ionic compound must have an overall charge of 0. Our sodium ion currently has a charge of 1 plus. We put the number first. However, we don't need to put the 1 there. In the case of 1, the plus or the minus is good enough. Chloride has a charge of 1 minus. One way we can picture this is as a number line. There are other ways of doing it though. So at the moment our sodium is sat at 1 plus and our chloride ion is set at 1 minus. Now 0 is our target. So we need to get there. How many do we need of each? So we can see with 1 of each we can then jump. If we add 1 minus to 1 plus, we reach 0. This means our formula for sodium chloride is NaCl. It has a 1-to-1 ratio. There's 1 of each element in that compound. If we look at a different example, so we've got iron and chloride ions here. Iron has lost 3 electrons and formed a 3 plus ion. Those 3 electrons are signified by the 3 green dots. A chlorine atom can only take on board 1 of those electrons to form a full outer shell. If it took on all 3 of those electrons, it would then have to put 2 of them in another shell, and unfortunately that atom would then be unstable and that wouldn't work. So if we do the same thing as we did on the last slide, our iron atom has a 3 plus charge, so we're going from 3 plus to 0 with 1 ion. Our chlorine ion only has a -1 charge. That means at the moment we are overall sat on +2. That means we need to change the number of chlorine atoms present in order to accept those 3 iron electrons to become chlorine ions. Now, as we said, with 1 chlorine, we are now currently sat on +2. We have a difference of 3 plus and 1 minus. Now, we need to get to 3 minus on the left-hand side in order to equal out the right-hand side of our number line. Now, each chlorine only has a 1 minus charge, so we'll have to do it in jumps of 1. We can't make the jumps any larger. So we can see how many more we need. That means we need 2 more on top of the one that we've already got of chloride ions. This means that our formula for our compound is FeCl3, and we need to make sure that 3 is below the level of the text. That's really important. Some ions aren't just single elements, some ions are compound ions. That means that our ion is made up of multiple elements. There are 4 that we need to know. The first is the hydroxide ion. Its formula is OH and it has a charge of 1 minus. So we put a little negative charge up there. The second one we need to know is the sulfate ion. This is SO4 and it has a charge of 2 minus. One way of remembering this is the acid sulfuric acid, which you needed to learn the formula for your core science, was H2SO4. Hydrogen is in group 1, and even though it's not a metal, it can form ionic compounds. If it's in group 1, it's going to have a charge of 1 plus when it forms an ion. If we have 2 of them, that means that we're going to have an overall charge on the 2 hydrogens of 2 plus. For the charge overall on the H2SO4 to be 0, the SO4 must have a 2 minus charge. The next one we need to know is our nitrate ions. which is NO3 minus. That means it has a charge of -1, and again can be remembered from our acid HNO3 in a similar way to the sulfuric acid. The very last one is our carbonate ion, which is CO3 2 minus. One way of remembering this is thinking calcium carbonate. You just need to remember the CO3, unfortunately, but calcium carbonate has a 1-to-1 ratio and calcium's in group 2. So if you've ever had a chance to look really closely at sodium chloride, i.e. table salt, then you will notice that it forms cube-shaped crystals. Now this is a higher tier subject, so please ignore if you're only doing foundation. Because of the attractions between positive and negative charges, the atoms line up in a regular arrangement. Now you can see that if we have sodium as our purple one in this diagram, that is positive. And if we have our green one as chlorine, just because chlorine's a little bit bigger, that's negative. We can see they alternate. So for each positive ion, such as this purple one here, there are 3 negative ones surrounding it. That's the one at the bottom. If we look slightly higher up, so for example this sodium here, there are 4 around it. That's just in one dimension. Across the other dimensions we can see the same. So if we go for this sodium one here, there are chlorine ions surrounding it. We can see the same for the chlorine. So if we start with this one here, we can see that there are sodium ions surrounding it. Let's pick a different one. Let's go for this one just here. We can see that there are sodium ions surrounding it. And just to prove the point, in the other plane as well, if we go for this one here, again we can see that there are sodium ions surrounding it. This regular arrangement of ions is called a lattice structure. And there are really strong forces of attraction between those ions called electrostatic forces, which make ionic compounds really strong. So onto our properties then. Properties of ionic compounds are that, first off, they will conduct electricity when they are molten, or i.e. melted, or they are dissolved, if they dissolve. They will not conduct electricity if they are solid, and we will talk about why that is in a second. Again, that is higher tier only, so you do not need to know why if you are just doing foundation. And secondly, they have really high melting points and also boiling points. Again, you need to know why if you're doing higher, but not if you're doing foundation, and we'll talk about that in a second. So the first bit everyone needs to know, and then we'll go on to the higher tier only. So first off, melting and boiling points. Now you need to know kind of what they look like. So if we take sodium chloride, for example, then we will have a melting point of 801 degrees centigrade. We will have a boiling point of 1413 degrees centigrade. These are really high. If you think about oxygen, oxygen is a gas at room temperature. That is a covalent compound, a simple covalent compound, and we'll talk about that in another lecture. This is the end of part 1 on ionic bonding. If you're looking for part 2, please go back to my YouTube page and look for ionic bonding part 2.